Welcome to Getting Started with SQL. So there are a lot of great talks throughout this conference. I would say SQL is one of the more basic topics or talks that we're going to be talking about, but it's one of the most important ones. So I want to preface by saying that this presentation is for complete beginners with no prior experience. And it's not for those looking for a deep dive tutorial into SQL. So I'm going to be doing a lot of explaining of concepts and keywords and a little bit of programming and a demo, but the majority of this is for complete beginners. So again, my name is Alice, currently a data science and analytics instructor. A lot of my tutorials can be found on A Dash of Data. That's my brand on YouTube or in GitHub. Today, I want to be talking to you again about SQL. And so in the past, I've held all these roles that you'd see here, data scientist, data analyst, and so on. And in every single one of my jobs, I use SQL. And so what I did was I took everything I learned from the past 15 years and I put it into my book, SQL Pocket Guide. And this is the table of contents of the book. Today, we're going to be focusing on chapter 1, the SQL crash course. I take everything from that chapter and I blew it up into this presentation you see here. Let's get started. So today, first, we're going to go through the SQL basics, an example database. I'm going to get into a little bit of SQL code because there's a ton you can learn in just about half an hour. And then we'll do a software demo. And the reason I do this is a lot of times people will see my presentations and they'll be like, great, I see slides with code, but how do you actually write the code in the real world? So that's why we have this short demo at the end. So let's get started with the basics. And we're going to start really basic. We're just going to start with the term data. So what is data? It's information stored by a computer. And there's lots of different types of data, numeric data, text data, and more complex data like sound, images, video. Okay, so that's data. So then the next question is, what's a database? And a database is this place to store data in an organized way. So the way I like to talk about this is imagine data is this Lego piece. And then everybody's always talking about big data and a lot of data. That's basically this huge pile of Legos. And then I would say a database looks something like this. So I'm really big into home organization. And so I have a lot of home organization examples throughout here. But a database is essentially that piece of furniture right there. It's that cart where you can organize all your data in this really nice way. So there are so many ways to organize data. These are all different home organization tips from Instagram. But you can see this is a really good analogy for organizing data, organizing your Legos at home or organizing your data at a company. There are many different ways to organize that data, and there really isn't a wrong way. It depends on your company and the situation, and you can organize your data in a lot of ways, just like these Legos are organized in different ways that work for these homes. Okay, so checkpoint, data is information stored by a computer. A database is a place to store that data, and there are a lot of ways to do so. And the two types of databases that people always talk about are SQL databases and NoSQL databases. So let's start with SQL, because that's what we're all here for. SQL stands for Structured Query Language, and I want to focus on that language piece. So imagine you have an app on your phone that's a birthday app. It stores information about all your contacts' birthdays. In the English language, you would say, hey app, when is my husband's birthday? And it would return this value. And if you were talking in the SQL language, you would say, select all from birthdays where person equals husband. So it sounds kind of like a robot, but because it's a programming language. And then you would get that same result. Okay, so now we know SQL is the language. A database is a way to organize data. A SQL database is data organized specifically into tables. So we have a table right here. It has columns, it has rows. And if we had a bunch of other tables and they're all connected to each other and they're one big family of tables, that whole thing would be called a SQL database. And sometimes in textbooks, you'll see tables called relations. And so this is sometimes called a relational database. So a SQL database or a relational database, they're the same thing. It's just basically this big group of data organized into tables. And then you can talk to that database using SQL, the SQL language. So I could say, select all from birth year, and then that would give me information from that database. Okay, we've been talking about a lot of theory, but let's go through a real world example. So imagine you had this app on your phone. If you have an iPhone, you see the Messages app, and you have a lot of conversations in that app. So, fun fact, the data that is in the messages, it's actually stored in a database. So this is a database that you can access. So I have a MacBook and an iPhone. I can just go to my MacBook and then I can pull up this ChatDB. And inside this chat database, there are a bunch of tables. So there's a handles table that has information about all my contacts' phone numbers. And there's also a message table that has all the text messages that I've sent and received. So let's say that we wanted to see all the messages that have been liked. So if you're not technical, you could go on your phone and you can just scroll up forever until you see all the messages that have been liked. But if you know the SQL language, you go to that ChatDB that is on your MacBook, and you can write some SQL code, and it selects all the messages that have been liked. And then it would return this. So this is a real world example of how SQL is so close to your everyday life, even if you don't know it. Okay, let's summarize what we've gone through so far. So SQL is structured query language. A SQL database is made up of tables. Those tables are called relations. And the SQL database is sometimes called a relational database. So another thing I want to mention is that SQL databases require these predefined schemas. So you can think of a schema as a plan or blueprint. So basically, before you start putting data into a SQL database or storing your data in there, you have to first come up with a plan. So you got to think, this is what I want my tables to look like. This is what columns should be in there. So if I was to put SQL into a SQL database, first I would have to say, okay, this is the table I want. And then I would throw data in there. And going back to home organization, it's like saying, okay, I bought this piece of furniture. Now I'm going to label these drawers of what color of Lego should be inside. And then you put the Lego inside. So again, these are all attributes of a SQL database, which is where you have these highly organized tables. Okay, so you'll hear about these NoSQL databases. And this isn't our focus here, but a question I get all the time is, what's SQL versus NoSQL? So NoSQL stands for not only SQL. And in a NoSQL database, again, a database is a place where you store data. In a NoSQL database, you have these dynamic schemas. That means there's no predefined structure. So instead of saying, my table should look like this before I put data inside, you just start throwing data in the database. So one popular NoSQL database is MongoDB. And in MongoDB, the data isn't organized as a table. It looks like this. So basically, throw in data about Lily, and then you throw in different data about Henry. And that's just how this database is organized. So going back to the home organization example, imagine if you had a room in your house where you stored all your Legos. A NoSQL database would be like, you get the classic Lego set and you just put the box in there. You get the Harry Potter set and you just put the box in there. And you just put the boxes in there, and maybe everything isn't organized by red, orange, yellow, but it's still organized in some way. And that might work for your household, or this NoSQL database might work for your company. So there are so many NoSQL databases out there. But in general, what I want you to get out of this is that NoSQL stands for not only SQL, and it's called a non-relational database because data isn't in these organized tables. Okay, at this point, we've gone through all these terms here. So what I'm going to do on the next slide is take all these terms I just introduced and summarize them in a few sentences. Okay, SQL is a language, and we use it to work with a relational database. So here's what SQL code looks like, and here's what a relational database looks like. And you can see the data is stored in these tables, which are also called relations, and they have this predefined schema or this predefined plan before you load the data. And then a less rigid way of storing data is using NoSQL, also called a NoSQL or a NoSQL database or a non-relational database. Okay, so those are our basics. Now that you have the terminology, let's dive into an example database. So today we're going to imagine that we work at a school and we want to keep track of all the students and all the grades. So typically what happens is when you are storing data for the first time, you're going to store them in spreadsheets. And that's totally fine. I would say it works for a lot of the cases out there. But let's say we're running into a few issues. So currently the data is a lot of spreadsheets, but there's no single location for the data. So teachers are trying to access the data, but they can't talk to each other. Like they have to talk to, they can't get the data in the same place. They have to talk to another teacher to get their data, to get student grade information. And also the data needs to be locked down. So maybe someone keeps deleting data in one of these spreadsheets that you're collecting student grades. Let's say the student body is growing and there's a lot more data to manage. And so you're trying to find a better way to deal with this data than just keeping it in these spreadsheets. And so we create the student grades database. And in the student grades database, we have a students table and a grades table. So let's dive into these tables. First of all, we have these IDs. So one thing in SQL that's different from typically using Excel or spreadsheets is every row has to be unique. And so every row here is unique and it has an ID, and these fields are called primary keys. So student ID is the primary key of the student table, and grade ID is the primary key of the grade table. Okay, so now let's look at these rows here. So what's interesting here is you can see that these two tables connect to each other. So Alexis is in row 1 in the students table, and then you see she has 3 grades in the grades table. So you can match rows in one table with rows in another table. And another thing to note here is that one student can have many grades. So this is sometimes called a one-to-many relationship. Okay, so this student ID here, you can see that it matches that student ID in the table above, and it's called a foreign key. So if we summarize everything we just talked about, we can put it all into one image here. So this is sometimes called a data model. So if you're starting at a company for the first time and you want to know what their data looks like, you ask them for the data model. And this will give you an idea of everything we just talked about in the last few slides. So this database has 2 tables, the students table and the grades table. And you can see all the columns in the tables. And then both of them have that primary key or that unique ID, and it's labeled with PK. Also, there's this kind of funny looking fork symbol, and that says that one row in the students table matches many rows in the grades table. And then finally, that student ID in the second table is a foreign key, meaning it matches the primary key or the unique ID in that first table. So here, that was your example database. Now that we have this example database and you understand the table, let's move on to writing SQL code. So what do we know so far? We know the basic SQL terms and concepts, and we have this database that's ready to look at. So what we can do now is we can either read data or edit data. So most people read data from a database, and you can start here or even just end up here. So if you're a data analyst, data scientist, you're going to be reading data from a database. Other people can create tables, modify those tables, like insert rows or delete tables even. And those people have roles like data engineer, DB admin, and so on. But we're going to focus on reading data because that's where people usually start. Okay, so let's get into the coding basics. I've been talking about reading data from a database, but in SQL terms, you query data from a database. So just remember, SQL stands for structured query language. So the most basic SQL query you can write looks like this. And one thing I want to note is at the top, we use query like a verb, and down here, we're using query as a noun. So if I were to use both of those in a sentence, I would say, I'm writing a SQL query to query my database. There's just the terms query everywhere. So in English, what this is telling me to do is show me all the data within the table called my table. So let's break down this query here. So in purple, these are your keywords. So every computer programming language has keywords. That means a word has a predefined usage to it. So select and from already have meanings when it comes to coding in SQL. And this is the table that has the data in it that I want to extract data from, that I want to read from. And the star means all columns. And I end every SQL query with a semicolon. So whenever I introduce this, students always say, what about capitalization? Does it matter? And the answer is no. SQL is case insensitive. Whether you write capital select or lowercase select, the code will run the same. But typically, keywords should be in all caps and everything else should be lowercase. All right, so this is our students table. So let's do our basic SQL query on that. So select all from students. If we did that, this is the table we get back. And you can see it's the exact same table. So this is the most basic SQL query, which is get everything from this table. And if we just selected the student name, then we would only get that student name column. And then if we did student ID, student name, you can see I would get both those columns. So you're kind of sensing a pattern here. You can see that with the select keyword, what that does is it tells me what columns should be displayed. If I look at the from keyword, it's telling me what tables should I pull from. So these two keywords, select and from, are part of this larger family of keywords that some people call the big six, or these are the 6 keywords you should know in SQL. So going forward, instead of calling it a keyword, I'm specifically going to call this the SQL clause. That's how people typically refer to different parts of a SQL query. So the first part is the select clause, and next we have the from clause, and these are the 6 main clauses when you're working with SQL. So next, let's go to the where clause. So here's our students database. If I added the where clause in here, what happened is it would look at the student ID column, because I'm saying where student ID is 101, and it says, oh, these 3 rows have 101 in them. And then it would return those 3 rows to me. If I did a slightly more complex query, you can see here I'm doing course name is Intro to SQL and final grade is greater than 90. And what would happen is, well, first, if I write this query, I would look at the select clause first. So it's going to say, okay, well, it says you want to select these 3 columns. Great. Now, within those 3 columns, these are the cases where course name is Intro to SQL. These are the rows where final grade is greater than 90. So which rows have both of those things? And you can see that's only the first row. So only the first row and those 3 columns would be displayed. Okay, now we're done with half the SQL clauses, the main SQL clauses. We're going to skip a few and go down to the order by clause. So with the order by clause, if I said select all from grades, so that's everything in that table, I can order by final grade descending. So if I order ascending, it's lowest to highest, descending is highest to lowest. And I would get this here, and you can see the final grades are descending. I can also do something that's really commonly done, which is using the distinct keyword. And this is typically used within the select clause. Sorry, not typically, it's always used within the select clause. So a distinct is like a unique. So this is saying, show me the unique course names. So I'm going to go to this course name column. There's some duplicates here. I only want the unique ones. And at the end of the day, I'm going to order it by course name. And you can see this is my result here. So from these SQL queries, you've probably seen it's all about reading. You have this big table, and you're going to read different parts of the table and extract just different parts of that table. That's what querying is all about. Okay, we've gone through the 4 simpler query SQL clauses. So now let's move into some of the more complex ones. And the most complex one of this whole presentation is this group by clause. So here's our SQL database, and here's a query that uses the group by. If I read the first line of this code, this is actually a comment. So anything that starts with dash dash, if you write something after it, the computer won't read it as code. It's just whatever notes you want to take along the way. And you have comments in every programming language. Next, let's go through the group by. So in this case, we're grouping by student ID. So student ID, you can see we have 2 student IDs. We have student ID 101 and student ID 102. So what group by does is really cool. It's going to look at just student ID 101 and do something with those rows. And then it's going to look at just student ID 102 and do something with those rows. So what should it do? That's when you move on to the next part. So group by again, that's grouping. But in terms of what it's going to do with that, you look back up in the select clause. So here it says average final grade. So what you're going to do is for the first group 101, you're going to look at the average final grade for that. And then for the next group 102, you're going to look at the average final grade for that. So that, if I average all those, I'm going to get a number. If I average all those, I get another number. And that average is called a function. So a function is just a calculation. One of many functions in SQL. We have average, min, max, count, and so on. Another part of this query, you see this as average grade. What that's doing, it's telling you in my final result, what should that column look like? And so it's saying, when I average my grade, I want to rename that final column as average grade, you see here. And that is called an alias. Okay, so from here, with this SQL query, we've been able to use this group by again to group the 101s, the 102s, apply some function, which is the average of all the 101s and 102s, and then rename that final column. So here's my 101s, I average. Here's my 102s, and I average. Okay, so one thing to note here, this is a little bit more in detail if you're not a true beginner, but one thing students always mess up when they're first writing code is that whatever you group by in the group by clause, you have to repeat that same column in the select clause. So that might be a little bit more advanced if you're a complete beginner, but it's just like a tip that you should always know when you're writing SQL queries. So now we've done group by. Our last clause is having. So what having does is if you've grouped your data in some way and you want to filter that, then you use having. So this is the code that we just went through. If I were to add an extra line on having, it says having average final grade greater than 90. What that would do is it would take my final table and only return the rows where the average grade is greater than 90. So it would remove that second one. So the tip here is you should only use a having clause when a group by clause is present. So having, I would say, is used less than all the other clauses just because it's only there if there's a group by. Okay, so those were our 6 SQL queries, SQL clauses in this query. So now let's pull that all together into one final example, just so you get a good sense of every clause in action. So here's our database again. Here's a huge SQL query, but it's really not that bad. So I'm going to go through every section in detail. Okay, here's a query. Here's the end result. So first thing, select clause. What's happening in those select clause? Well, that's what you're going to, those are the columns you're going to see in your final output. Okay, next we have our from clause. This is a little bit more complex here, but what this join is doing is it's telling me I want to get data from the student table. And I also want to get data from the grades table. I'm going to connect them together using that student ID. And then the combination of two tables, that's where I want to query from. Now we have a where clause. So here this is saying, I don't want to see situations where the final grade is 0. So the 2 carets, that's saying not equals. So only show me situations where the final grade is a number, not just 0. And then we have our group by. So again, our group by, we're group by student name. So for student Alexis, for student Brianna, I want to be able to aggregate their data in some way. So just remember that student name is also in the select clause up there. And what I'm going to do with each student name is I'm going to find the average final grade for that student. And those are our 2 final grades. And those end up going into our final table here. And then we have having, which is filtering that final table. So we're saying only give me the students with grades greater than 90. So remember we had Brianna here, but she disappeared because of that having. And then finally, there's the order by. So we only have one situation here, but with the order by, you'd be able to sort that data. Okay, so we just went through all the clauses in the SQL query. So one thing to know is the SQL clauses must always be listed in this order. So it's a good idea to remember the order of the clauses. And if you have a hard time doing that, a mnemonic that I came up with that I like is start Fridays with grandma's homemade oatmeal. So that will give you select from, where, group by, having, order by. So to summarize this section, beginners often start by querying a database. And then in a query, when you write a query, the clauses, they must always be written in the same order, which is the order you see here. So as a checkpoint, we've done a ton. We've learned the basic concepts and terms. We've gotten familiar with the data. We understand the structure of a query, which is those 6 clauses. So now let's practice coding. Okay, so last we're going to do a software demo. Okay, so now that you know all the basics of SQL, where can you write SQL code? The answer, there's so many places to write SQL code. You can write it in a ton of software, which I'll go through in detail. There's database tools where you can write SQL code, and you can also write SQL code within other code. It's pretty amazing. So the demos that I'm going to do today are within SQLite and dbeaver, which is software and a tool. Okay, but let me explain what those are before I go into them. So first, what is this acronym? It stands for Relational Database Management System. What does that mean? It's basically software you use to work with the database or place where you can write SQL code. This is a table of all the popular softwares out there. So I've listed 5 here, and you can write SQL code in all the software. So how do you choose which one to write in? Let's start with the first one, Microsoft SQL Server. That's owned by Microsoft, which means that you have to pay money to Microsoft to use Microsoft SQL Server. And so typically you would use this if you're already working at a company and you want to work with other Microsoft products like Windows. Like if you're on a Windows machine, you might use Microsoft SQL Server. If you're using Azure, things like that. And then there's MySQL. So MySQL is open source, meaning it's free to use. And this is typically used if you're already in web dev. So if you're using HTML, CSS, JavaScript, use MySQL. Oracle is another one that's used by big companies. So it's proprietary, meaning you have to pay money to use Oracle. Postgres is open source, meaning it's free to use. And it's usually used by data scientists. So that's the background I come from. So I'm familiar with Postgres, and it's usually used along other open source data science tools. And then finally, there's SQLite. SQLite is also open source, which means it's free. And it's used if you're doing any app development. So just like I talked about with that little messages app in my example early on, all that data is held in a SQLite database. Okay, so I have a SQL fun fact, which I call a slightly fun fact. SQL syntax varies slightly from software to software. So this is a little bit confusing because you're learning SQL right now, but the syntax is actually different a little bit in each software. So let's say you want to return 10 rows of data. Then you have your RDBMS, and then this is what the code would look like in that RDBMS. So you can see it's different. There's 3 different ways to write how do you return 10 rows of data. It should be really straightforward. So my pro tip for you is that when you're Googling SQL syntax, include the RDBMS in your search. And I say this because I learned this in a very hard way. In my first job, I was using SQL Server, and I knew how to write top 10. On my next job, I used an RDBMS called Teradata, and I would Google how to write SQL queries, and then it looked like it should work. And then when I plugged in the code, it didn't work, and I could not figure out how it wasn't working. And I realized, well, it's because the syntax is different in every database. So in that case, if you're Googling SQL syntax, do return 10 rows, MySQL, return 10 rows, SQL Server. Okay, so the takeaways for this section is there's so much software out there. So I talked about these RDBMSs. There's a ton of cloud-based software as well. So like Redshift, BigQuery, Snowflake. And it seems intimidating because you're like, how do I learn them all? And the answer is nobody knows them all. But all you have to know is, although each one has slightly different syntax, the core concepts are the same. So I was using SQL Server at one job, I moved to another job, I was using Redshift, and you basically just open up a different software and you're writing SQL code. Sometimes it breaks, you Google it, and then you slightly tweak it for that software. So because this is a beginner course, I wanted to introduce some free resources for SQL. So if you want to get set up on your computer, if you want to start writing SQL code very quickly, I would use SQLite. It comes pre-installed if you have a Mac, and it's just really easy to install if you have a PC. And then if you want to start writing queries in a web browser, I would use, I'm not affiliated with them at all, but I really like w3schools.com. They have these databases already set up, and then you can just write SQL queries within your web browser. So that allows you to get used to the syntax before even downloading anything onto your machine. Okay, so I'm just going to do a very quick SQLite demo because everything looks nice in the presentation, but what does it actually look like when you are working? Okay, here is my terminal window. And for any RDBMS, if you want to just interact with it in its most raw form, you can access it in a terminal. So what I'm going to do here, I'm going to open up SQLite. So again, it comes pre-installed on a Mac. I'm going to type in SQLite 3, and I've created this student grades database. So if I do that, I'm using SQLite now. So from here, I can look at the tables I have available. Great. And I can write a SQL query. Select all from students, and you can see all my students. I can make it a little bit more complex even. Student ID is greater than 102, and you get that as well. This is a very, very basic way of writing SQL code, is again within SQLite. Okay, let me get back to my presentation here. All right, now we've gone through our DBMS software, which again is relational database management software, and that's where you can write SQL code. I would say try not to write SQL code directly in an RDBMS. You really want to be using a database tool instead. So what is a database tool? It's a tool that has a graphical user interface, or GUI. So instead of that ugly black and white screen I was just showing you, instead, you want to be able to click things and things pop up for you, and you want to have a nice environment to write SQL code. There are so many database tool options. A few of them are free, and I've listed them below. So for the first four rows there, you'll see that people, when you use the Microsoft SQL Server RDBMS, you'll typically use SQL Server Management Studio. Or if you're working with Postgres, you'll use pgadmin as your database tool. Those go hand in hand. SQLite, there's many options. I like to use DB Browser. And then there's a ton of tools out there where you can connect to multiple databases. So I like to use dbeaver because it's free, but I know people love to use Toad and so on. And it just allows you to connect to a lot of databases and write in this user-friendly environment. So let me share my screen again. So here's dbeaver. It looks really nice. What I'm going to do is I'm going to connect to my SQLite database. So there's a ton of options here, and I'm going to choose SQLite, but just to show you, like, these are all these different databases you connect to. There's also NoSQL, big data, and so on. I'm choosing SQLite, and then my student grades database is right on my desktop, and I'm in. Okay, so from here, look at all these things you can click on. You can look at the grades table and the students table. These are the columns in the grades table. These are the columns in the students table. So you're seeing that this database tool is a much better place to write SQL code. And now if I want to write SQL code, I'm going to open up a new SQL script, and I can do my select statement. Select all from students and get this nice thing here, where student ID is greater than 102. And you get this nice thing here. And you can see in my result, you can also, oops, are you sure you want to load? Oops, nope. You can also filter and sort. So here I've been sorting back and forth. Okay, so this is, again, dbeaver. It's a free database tool that I use to connect with our DBMSs. Okay, so we've covered our DBMS software. Again, don't use those in their raw form. Go use a database tool. I recommend dbeaver for free. And another place where you can write SQL code is in other programming languages. So we all know there are a ton of programming languages out there. You can create apps with it, do analysis, and so on. But if you're working with data, you're going to need a database. And if you're working with database, you're going to need to use SQL. So let's say you're a developer and you typically code in HTML, CSS, JavaScript. You're going to have to store your web data somehow if people fill out forms. That's going to be stored in a SQL database. If you're an engineer, you code in MATLAB, collecting sensor data. That needs to be stored in a database. If you're an analyst who uses Python or R, have to analyze customer data, that data is going to come from a database. So basically, I would say if you're working with data, like in any of these roles, you're going to need SQL. So the cool thing is that you can connect SQL to many other programming languages. So if you are working as an analyst in Python or R, you connect to a SQL database, and then you can write Python code and SQL code alongside each other. So let's say I'm coding in R, and I have data in two databases. Maybe there's a MySQL database and a SQLite database. What I need to do is install a database driver. And it sounds kind of intimidating, but it's not. You basically just install this program on your machine. One's called RMySQL, one's called RSQLite. And what that database driver does is it allows R and MySQL to talk to each other really seamlessly. It's awesome. So let's say we had, here's an R example. Let's say If we're trying to connect to our SQLite database, you can see the green, that's where you're connecting R to SQLite. Once you do that, that last line, you're writing SQL code. And it's this mix of R and SQL code. Same with Python. I import the SQLite module that connects me to my database. And then at the bottom, again, I'm using pandas, which is a Python library with SQL. Okay, that is your crash course in SQL. So let's summarize everything that we've talked about. This is my one pager that you can also find on GitHub. I have a GitHub link on the next page, but this summarizes everything we've talked to today. So key terms. We know a database is a place to store data in an organized way. Most of the times, data will be stored in a relational database, and you use SQL to work with that database. So if you're just starting with programming for the first time, SQL is a great first programming language to learn because it can be used almost everywhere. This is what a data model looks like, and it shows how everything is connected in a database. Data models aren't usually this easy. They're usually huge, and then all these tables are connected to each other, but it helps you understand how data is organized. And then the most important, I would say, key term in all that is to know what a primary key is. So it's the unique ID for that table. And then query can be used as a verb or a noun. So you query data from a database, and you also write a SQL query to read data from the database. And these are the main SQL clauses. Remember, you can remember the order with start Fridays with Grandma's homemade oatmeal. And the other thing to remember is that the syntax is slightly different in each software. So the pro tip there was when you're Googling, make sure to also include the name of your software in your Google search. And then finally, where can you write SQL code? In a lot of places, these are the most popular are DBMSs. And then if you're just getting started, I would say go to w3schools.com, or you can download SQLite, and then you can write it within other tools and other languages as well. Okay, and that's all I had for today.